Yes, I was right in the first point. Removing load resistance and redrawing same circuit. We get. I will draw the same figure here. How will be the figure? Just I'm removing this load resistance, everything will be the same. It will be something like this. This is right. This is plus, this is minus. In this case, this is hybrid network. Now hybrid parameter, H parameter. Generally, we will discuss such kind of the circuits in the devices, electronic devices and circuit, EDC. Boiser might have been discussed at this particular point to you. Here, in this case, this will be the figure. Here is the point A, this is point B. We have removed the load resistance. Now this is 3 ohm. This current is the 10I, where I is this current. Is it right? It is the 5 ohm. This is plus and minus. This is 50. And this voltage is VAB. That is voltage between these terminals, that is AB. Is it right? Now here, this current is I when this load resistance is existing. To differentiate that, what I will do, I will give some other name here. In this case, I will give this name as the I1. This current will be the I1. Is it right? To differentiate between the case 1 and case 2, that's why we are giving that kind of the names to this particular figure. Is it right? Now here in this case, this will be the circuit. Now what is our aim? Our aim is the calculation of voltage between these 2 points, that is A and B. Is it right? We are interested in the calculation of the voltage between the points A and B. This voltage means here in this case we have to calculate current in this branch. How is the current in this branch? Current in this particular branch is this current is flowing upward. Is it right? In this case this will be the plus polarity and this will be the minus because it is a current source. That is 10I. Is it right? That is 10I. Miss I1 here. Miss here we have to apply the KVL here and we have to find out its equation. So first we will apply the KVL here and then we will try to find out its value of the VTH, which is nothing but the Thevenin's equivalent voltage. We will start the discussion and we will see later on what happens to this particular figure. So here in this case, if we are applying the KVL to this particular loop, this will be the plus and this is minus. Already its polarities are known, and finally we will see what happens. That is first, because we are interested in the calculation of voltage, means 10 into I1. First we are trying to find out the I1. Yes, I will do that. Applying KVL to the loop 1. Applying KVL to loop 1. Apply the KVL or Kirchhoff's voltage law to the first loop and prepare its equation. If we are applying the KVL to this loop and if we are preparing its equation, how will be its equation? If we are starting from this point, we are traveling in the clockwise direction, negative to positive, which is plus. Its voltage is 5. Is it right? Then positive to negative, it is a minus. Its resistance is the 50 and its current is I1. This 50 I1 is its potential. Then we are traveling from positive to negative, which is minus. How much is that potential? VAB. This is VAB, and which is equal to 0. We are coming back. If we are simplifying this equation is minus 50 into I1 minus VAB, which is equal to minus 5. Means indirectly, it is 50 into I1 plus VAB, which is equal to 5, and this is the equation number 1. Is it right? We have the first equation, or equation number 1. Is it right? Now look at carefully. In this case, if we have this equation, in what value we are interested? We are interested in I1. But here VAB is another unknown. Now we have to find out VAB in terms of I1 or I1 in terms of VAB. That is the second equation which will be useful for the calculation of the parameters, because we have the two equation and single unknown. Single unknown may not be sufficient for the calculation of its values. Is it right? That's why here if we are finding the relation between these two, look at how I'm finding the relation. Whenever there is a voltage VAB, we will find out this relation. We are finding this value VAB. We will travel from the B towards A, because I am interested in the equation between VAB and I1. That's why I am finding the VAB. This VAB is equal to, how much is the VAB? This VAB is equal to, we are traveling from this point to this point, means positive to negative, which is minus. This is minus. Is it right? This is minus. And how much is the value? This is minus its resistance into its current. Its resistance is a 3 into its current. How much is the current? Current is a 10 I1. This current is a 10 I1. And this is the equation number 2. Or this is equal to minus 30 I1 is the equation number 2. Is it right? Now we have the two equations and two unknowns. We will find out the value of the two unknowns. Is it right? Here we can put the equation number 2 in equation number 1. Otherwise, this equation can be arranged in the different format. This VAB. Otherwise, I can arrange this equation in this format. It's how it will be. Minus 30 I1. Is it right? It is minus 30 I1. It is minus 30 I1. This value I will shift to the next side, means it is minus VAB, which is equal to 0. That is the equation number 2, maybe something like that. Now we have the two equation and two unknowns. Use your calculator and find out the value of its I1 as well as its potential VAB, which is equal to. Find out both values. Now look at calculator. I'm using this calculator. Is it right? If we are using this calculator in this case, here in this case, I'm shifting the calculator in the equation mode. Sorry, I'm using the calculator equation mode. Unknowns, we have the two unknowns. How is the first equation? 50. This is 50. How much is the second value? VAB 1. How much is the constant? That is 5. Next. How much is the value of A2? I will use the same equation. It is minus 30. The next is minus 1. How much is the next value? C2 is 0. Then X is the first value. First value is I1. How much? I1 is 0.25 amperes. This is 0.25 amperes. And how much is the next value? Its value is VAB is minus 7.5 volt. Now look at what is this VAB? This VAB is nothing but open circuit voltage, which is same as the Thevenin's voltage. Therefore, this VTH is equal to modulus of VAB, which is equal to modulus of minus 7.5, which is equal to 7.5 volt is the value of VTH. This VTH is found to be 7.5 volt. Is it right? I will come back to you and I will discuss. Anyone has any doubt regarding this? If anyone has a doubt, I will clarify your difficulties first and then I will move to the next part. I will come to you. Yes. Anyone? Akash, any difficulty? Akash, any difficulty?
No, sir. No, sir.
Avinash?
No, sir.
Chaya?
No, sir.
Then Chinmay? Chinmay Lakade? Unmute yourself. Chinmay? Yes.
No, sir. No difficulty.
No difficulty. Madhuri?
No, sir.
Rishikesh?
No, sir. No difficulty.
Ruchira?
No, sir. No difficulty.
Saurabh?
No, sir. No difficulty.
Sheikh?
No, sir.
No. So here, in this case, if we know the value of VTH, next step is the calculation of RTH. How is the calculation of RTH whenever we have the dependent source? Whenever we have the dependent source, we have to use the formula for the calculation of RTH. RTH calculations के लिए हमें formula use करना. Is it right? We have to use the formula for the calculation of RTH. Is it right? Just wait. My screen is stopped. I will clarify it first. I will check it out. What happened? Yeah. So here in this case, next step is the calculation of RTH. Just wait. I have some issues with my camera. Yeah. Now it's fine. Yes. It is fine now. Yes. Yeah. Now for the calculation of RTH, I will write here. For the calculation of RTH, we have to use RTH is equal to VOC upon ISC. This formula is right. Why we have to use this formula? Because whenever we have the dependent sources in the circuit diagram, we are not able to replace the sources by its internal resistance. That's why we have to remove those sources. We have to use this another method, and which is nothing but here that VOC divided by ISC is the RTH. Now VOC is the Thevenin voltage. We have already calculated. Now we will find out the ISC. Means we will draw the same figure. We will remove the load and we will short the output terminals, and we will find out the same value. Is it right? Now here I will use this figure. How is the figure for the calculation of RTH? I will write here figure for calculation of ISC. Is right. How will be the figure? I will draw it. This is the figure for the calculation of ISC. It will be the figure. Yes. This is the figure. We have to be very careful about some small and basic points while working with the dependent sources. Dependent sources में work करते समय हमें छोटी-छोटी चीजों को ध्यान रखना पड़ता है. I will discuss those. This point is the A point. This is the B point. This value is the 50 ohm. Is it right? This is 50 ohm. This current is the I. Here it is, this voltage is the 5 volt. It is plus sign minus. Is it right? And what we are doing? We are short circuiting these output terminals, and we are interested in the calculation of the current in this, which is the short circuit current, generally known as ISC. Is it right? So here, there are many ways for this calculation. How will we do this calculation? Otherwise, this current is I when load is existing. This current I have named it as I1. whenever this is removed, which is here, when it is removed, I have named it as I1. And whenever it is shorted, its name will be the different. That's why I'm naming this value as I2. This will be the I2. Just nomenclature will be the different. Is it right? And now we are interested in the calculation of the IS. I will come back to you. Can anyone able to answer this question? Which method we will use here for the calculation of ISC? ISC कैसे calculate करेंगे? इसको कुछ idea आ रहा है यहाँ से? Anyone is getting idea, something idea about how to find out its value of the ISC, short circuit current? Avinash, Chaya, Chinmay, Madhuri, Rishikesh, then Saurabh, Sheikh Naushad, and Shailesh Vattamwar. Anyone has any clue how to find out this value of the ISC, which is nothing but the short circuit current in this case? Yes, anyone? Okay, fine. Now look at here, how will be the methods? How will be the procedure? Now look at this short circuit. This short circuit is a parallel to this 3 ohm resistance. Is it right? First, I will draw its equivalent circuit, because many times what happens, many times whenever we have the short circuit parallel to any branch, better way to modify the circuit and then work out on the calculation. Here, in this case, this will be the figure for the next calculation, because I am modifying this figure. This current is the I2. This voltage is 5 volt. This resistance is a 5 ohm. This is plus, this is minus. This potential is a VAB. Here, in this case, this current source is 10 I2. And this parallel combination will be 0. Means between the A and B, here will be the short circuit, and this current is the ISC. Is it right? This current is the ISC, because whenever short circuit is parallel to anything, the current flowing through this branch will be 0. This complete current will flow through this particular path. Now look at the directions. We are interested in the current downward. We are interested in the current downward. And this current is actually upward, means from loop 2, we get. What we get from the loop 2? Look at here. This ISC is equal to minus 10 into I2. But always we have to take this modulus, because we are finding this value of RTH. We are finding this value of RTH. This RTH is equal to, it is VOC upon ISC. And this RTH is never negative. That's why this VOC and ISC we have to consider always both positive. That's why I am taking its modulus value. Is it right? This is very same as 10 into I2. But we have to find out this value of the I2 first. Is it right? We have to find out I2 first. Now what we will do, I will name this equation as equation number 1. Otherwise, I will keep it inside the modulus first. Then we will simplify it, and then I will take the outside of the modulus. Then applying the KVL to the loop 1. Here, applying KVL to loop 1. Is it right? We are applying the KVL because we are interested in the calculation of I2. ISC निकालना है तो I2 निकालना पड़ेगा. How much is I2? If we are traveling from this point, we are traveling in the clockwise direction, negative to positive, which is a plus 5. Is it right? Then this will be the plus minus. Then here it is minus 5 into its current, which is I2, then minus VAB, which is equal to 0. If we are simplifying this equation, this is minus 5 I2, this is minus VAB, which is equal to minus 5. This indirectly, this is 5 I2 minus VAB, which is equal to 5. This is equation number, I guess, this is the equation number 3rd, this will be the equation number 4th. Because already we have taken, this is equation number 1 and this is the equation number 2. That's why it will be the equation number 3 and this is the equation number 4. Now look at how we have the values. We are interested in the ISC. We are interested in the ISC, and this ISC is nothing but 10 into I2. First, we will find out the I2, and then we will find out this particular value, that is ISC. Is it right? So here is I2 and this is I2. Now look at here. Otherwise, we are interested in the calculation of I2 and VAB. Now we have to find out the VAB in terms of, because I2 and VAB, we want the two equations in terms of I2 and VAB. This equation I will consider it later on, because if I2 know, I will use this equation. But I'm interested in I2 and VAB, means we have to find out another equation. Is it right? How will be that equation? We will find out VAB. I will write calculating VAB. We get, because we have the two equations. If we have the two unknowns, one unknown is I2, another unknown is VAB. Is it right? Then we have to find out VAB in terms of I2 or I2 in terms of VAB. That's right. Is it right? And if we know the I2 or VAB, in that particular case, we are able to find out this value ISC. Now find out the VAB. Where is the VAB? This is A and this is B point. This is A and this is B point. How much is the VAB? Can anyone able to answer? Yes, Chaya.
सर
Yes.
वो रेजिस्टेंस का वैल्यू 50 ओम है ना, आपने 5 डाला है उधर.
Okay, it is 50.
यस सर.
Just wait, just wait. It is a 50, yes. Absolutely correct. This is 50. This is 50. Absolutely fine. Then here, in this case, this will be 50 I2, this will be 50 I2, this will be the 50 I2. Is it right? Which in this particular case, 50 I2 minus VAB is equal to 5. This is one equation. It is right now? Chaya. अभी सही है? Yes.
Sir, equation for 50 I2 plus VAB चाहिए.
50 I2 plus VAB. बिल्कुल सही. This is plus VAB. Right. It is right now. Is it right? अभी सही है? Okay, fine. Now here we are finding the VAB. Now can anyone answer how much is the value of this VAB? Can anyone is able to answer this value of the VAB? Rishikesh, Avinash, Saurabh. How much is the value of VAB? Look at here. How much is the resistance between A and B? 0. It is short circuit. That's why 0. Means Z, whatever it may be the current, its voltage will be 0. 0 into anything. Anything is that 10 I2, which is equal to 0. That is the equation number 5. Is it right? If we are putting the equation number 5, putting equation number 5 in equation number 4, look at how we will get this 50 I2 plus 0, which is equal to 5. This I2 is equal to 5 divided by 50, which is equal. How much is the I2? How much is the I2? 5 divided by 50. Its value is 0.1 amperes. Is it right? This is 0.1 amperes is the I2. And if we know the I2, then we can find out its value of the ISC from this equation. Now, ISC is equal to, it is the modulus of minus 10 into I2, and this is very same as a minus 10 into I2, which is 0.1. How much is this value? 0.1 into 10. This value is 1 ampere. This 1 ampere is the value of ISC. Is it right? Are you getting me? This value is 1 ampere. If we know the ISC, then we can find out its value of the RTH. We can find out the RTH. Now look at here. In this case, now how is the formula for the RTH? Now this RTH is equal to VOC upon ISC, which is equal to, how much is the VOC? We have calculated its value. It is 7.5 volts is the VOC. Which in this case, it is 7.5 divided by ISC it is 1 ampere. This is 1. This here in this case this RTH is equal to 7.5 ohm is the value of RTH. Is it right? Now, when we know the VTH and RTH, then complicated network is replaced by the Thevenin equivalent network. I will write the same. When we know VTH and RTH, complicated network is replaced by Thevenin's equivalent network. Thevenin's equivalent network. How will be the figure, final figure? It is something like this. This is A point, this is B point. This RTH is a 7.5 ohm. And how much is the VTH? It is 7.5 ohm is the value of VTH. Remove the load resistance which is removed in the first step. How much is the load resistance which we have connected in the first case? Which is the 8 ohm. And we are interested in the calculation of the power. This is right. I will reconnect this load resistance which is 8 ohm. This is 8 ohm. First calculate its current which is IL. Now this IL is equal to VTH which is 7.5 divided by RTH is 7.5 plus RL is 8. Find out this value. 7.5 divided by 7.5 plus 8 is its value. Yes. How much is the value of load resistance? Saurabh.
0.48.
It is 0.48 amperes is the value of this IL. If we know IL, then power transferred, that is P is equal to IL square into RL, which is equal to 0.48 its square into RL, which is 8. How much is the power transfer? Yes, anyone?
$1.84.
1.84 watt is the power transferred to this load. 1.84 watt is the power transferred to the load, and thus we have calculated by using the Thevenin.